Hey, welcome to Endris Science. This is going to be episode 5 of these videos that I'm making to help teach NGS in the classroom, especially concentrating on earth science right now. That's what I'm on. And we've been dealing with the earth science performance expectations from, if you know your numbering, from MS ESS 2.1 through 2.3. So, and that deals with, our first one was, how is this the rock cycle working? But not really the rock cycle, not really matter, but what is happening with the energy inside of that, the energy that's leaving the core and it's making the mantle move, and that's why it's making these the surface of the earth move. And then we kind of went into, well, why do we think the surface of the earth is moving? So that's what the whole idea behind the plate tectonics performance expectation is not that we tell kids there are plates and they are moving and here's what happens at the boundaries, but here's why we think that's happening. Present the information to students and let them kind of figure out, hey, it sure does look like the Earth's surface is moving. And then, the idea is so that they can kind of get that feel of that scientists felt, 40, 50 years ago, well, 60, 70 now, of, hey, it certainly looks like something weird is happening here. The surface of the Earth must be moving. And so anyway, and then we went into, because the plates are moving, we can also see how that affects the land around them. And so we also talked about landforms that are created because of plate tectonics. Well, now we really are on part 2 of that, because we dealt with the rock cycle and we saw how the energy from the earth helps in creating igneous rock and metamorphic rock. And now we need to talk about how energy from the sun helps to make sedimentary rock. And then we talked about over here, we already talked about how the energy from the earth moves the plates, and the plates can cause these different landforms like mountains and volcanoes and islands. And so now we need to deal with over here other landforms that are created by different processes like weathering, erosion, and deposition. And so that's really the big idea in these 3 performance expectations, is that the earth surface is changing. And it's changing because of energy from the earth and energy from the sun. Okay, and then we're getting different types of rocks, and we're also getting different landforms because of the energy from the earth, plate tectonics, and energy from the sun, which is now going to be wind and water. Okay. Anyway, I will start this. So the way I start teaching this with weather and erosion deposition is I do it with a stream table. I find that that's by far the not just the easiest way, but also the way that makes the most sense. Now, what you could do, and it depends on if you are teaching earth science standards all in the same year, right? You could also start teaching with wind and how wind is made. Wind is made by the uneven heating of Earth's surface, and I save that for when I do weather, because that's going to be one of the primary or what's primarily responsible for weather is the sun's uneven heating of the Earth's surface. And so I have an experiment that I do with that. If you want to do it right now in the course to introduce weather and erosion, well then fast forward a couple episodes, and for when future events deals with how wind is created with weather. But for right now, I just introduced stream tables. And if you've never done a stream table before, well, you've been missing out. Okay, it's a terrific lab. Students enjoy doing it, but they also can learn so much from it. But it also, it deals with water and land, so it really shows you how water affects land. And these are pretty easy to do. If you haven't done it, you can make one of these yourself. You just need really some kind of tray. You can get these from the store, like a plastic tray. But also, even if you just have like an aluminum foil tray, like this really long tray or something, and what you do is you prop it up on some books or something so that it slants down, and then you fill this part of it with sand, so that when you put a bowl or something here, and with a hole in it, you fill it with water, and then the water will come down, drip out of the bowl, and it'll start to hit the sand, and the sand will start breaking down, right? It'll start weathering. And so that will come and it should form a little delta here, and then the water will go down here, and then you make a little hole in the bottom and it trickles down. Now, if you have never done this before, make sure when you do it that the table you put it on is back here, because if you put the table really close, it'll stream down and it'll come back and it'll hit the table and it'll run off and it'll make a big mess. But anyway, this is essentially a stream table. Weather and erosion, they're really two different things, but you can call them the same thing. Technically, weathering happens right here, where the rock is being broken up, and then erosion happens when the water or wind is taking the sediments away. So this is weathering, this erosion. So they're both a destruction of land, and that's one of the things we focus on, is that it's destroying the land. And then this right here, this deposition, is where the new stuff is being set down and it's making a new landform. And so just like with plate tectonics, I'll ask my students, one of the discussion questions I'll have is, when I introduce weather and erosion, well, if weather and erosion are destroying land, then does that mean that the earth is getting smaller, that the land will soon all go away? And it's interesting, you'll get some pretty neat answers for this, with students wondering, well, where is that stuff going? Well, it's going here because it's being deposited. So those are the concepts that you want to introduce here. This is also good because you get to explore models more. So you've already done that, hopefully, with the convection currents in the earth. But here you can talk about more of models and limitations of models. So what is a model good for? What is it bad for? Well, what is it good for? Here, I mean, we've taken this huge thing like a river and we've condensed it into the classroom. And we can also easily show what weather and erosion deposition are, because this really is real water working on real land, and it's making landforms. So we can see how that works. The limitations of it are, just to name a few, is that, well, our water only comes from one water source. And so if it only comes from one water source, it's not like the real world, which we might have rain all over. Another thing is that we get to control the slant to it, and there's no plate movement. Okay, so in the real world, there's plate movement that you have to account for. The next thing, there's a tray here, and that's a limitation, because in the real world, water just keeps cutting deeper and deeper into the earth and doesn't stop. So anyway, those are all limitations of our models. Students get confused sometimes with limitations because they'll just say things like, well, it's not the real world. Well, yes, I understand that it's not the real world, but how is that limiting our understanding, right? Well, there's not books in the real world. Yes, but the real world does slant, right? I mean, there are downhill, so that's not really a limitation. What's the limitation of it? So anyway, you might have to kind of help them through that. Limitations are normally, the way I teach it is that it's somehow that it hinders our understanding. Like if you thought this was how the real world actually worked, that it worked exactly like this, there's something you're missing there, okay? And like I said, if you thought that it just comes from one water source and that's it, then you're not really going to understand how all those little tributaries and everything form and make a real river. Okay, with this also, I have them do a lot of different things with this. For instance, I have them do some engineering with it. So if you put like little houses or something along the stream, and the stream's gonna get bigger and bigger, and they're gonna see different ways that they can try to stop the erosion on a river. And usually this is done by building like dams or building levees or something like that. And they'll see that water just kind of redirects into another location. And so a good discussion that we can have is this really a good thing? Is this really something we should do? Because while you're protecting these houses, well, you're probably going to destroy other houses somewhere else, right? You're just rerouting that. And that's what's happening right now in Louisiana with the Mississippi River Delta, right? The Mississippi River should be the Mississippi River was destroying like all this land, and so they built all these levees and dams and everything. Well, now Louisiana is shrinking because it's not getting the deposition that it normally gets. And that's something that you can also look up and find a YouTube video on to show them that there's always these consequences in trying to limit the amount of weathering and erosion you get, trying to stop these natural processes from happening. And so that's something else we do, is we try to stop the erosion. I'll challenge them, who can build the best way to stop the erosion, and they'll normally find out, well, you can't stop it. It's eventually going to eventually going to happen. The best you can do is to take rocks or something and limit where it's happening. Also, what I would say is that if you're going to do this, I would say definitely do this, but also you can do it with wind. You can take one of these things and instead of water, just put the dirt in there and take a straw and blow on it and watch as the wind develops. If you put little rocks on the other side, then when you're blowing the wind, you'll see that the sand starts to collect around the rocks, and that's where it starts to build up. And you can explain that's how a sand dune is made, is that all it takes is a little bitty pile of sand, and that sand will keep getting bigger and bigger and bigger, and then eventually you'll have a sand dune. You'll have this huge landform. Also, when I teach this, after I do this, I will show them pictures from Google Earth, and sometimes I will. What I usually do is I try to let them explore Google Earth themselves if they have a one-to-one computer, and they'll look for these different things. And so you can find nice pictures of sand dunes. You can find nice pictures of deltas out there, and mushroom rocks. That's when a rock is cut from the bottom by sand and wind erosion. So anyway, I look for all of those. I have them look for all those different ways that weather and erosion affects the earth, and we can actually see pictures, of the real world and where this is happening. Before we leave this concept, though, I did want to point out that this is where I introduce. This is one of the first times. Usually, if I teach earth science in this platform, this is one of the first times where I introduce the scientific method. That's what we often call it. Variables, a controlled experiment, and so. A controlled experiment is one where we limit all of our variables, we keep all of our variables the same, we control them, except we change one thing, and that's called the independent or manipulated variable, and we try to see how that's going to affect the whole system. And then we measure it somehow, that's called the dependent variable. We measure the outcome to see what happened to our experiment, if our experiment worked. And so the way that I will do that is that I have them, they set up their table. So here's the sand, and what I'll get them started with is I'll say, I want to know what's the difference between if we take our ruler and we make little ruts in it that go the same direction, are they perpendicular, and then we do our stream table, we let the water go. And what about if we take it and we make ruts that are going parallel, right? What's going to be the difference? And when I say difference, I let them kind of pick out, well, what are you going to measure to see? Most of them will say something like they're going to get a ruler and they're going to measure just how far out the sand goes. Okay, so that's a perfectly acceptable thing, but generally I try to let them come up with, well, what exactly are you looking for? What's going to be your dependent variable? How are you going to measure the outcome? I like to point out also, like, this is a control variable. We're going to put 4 ruts over here, so we have to put 4 ruts over here. The only thing that we have to, if we bring our sand out to this part, we have to bring our sand out to this part over here also. Everything has to be exactly equal except that one thing that we're changing. So anyway, and then sometimes I'll have them come up with their own experiment. Like, this is my experiment, now you come up with an experiment. And so I'll give them little wood blocks or something to make houses, or I'll give them rocks or something like that. And they can experiment with, like, what does the sand erode more with rocks or without rocks? And then so they come up with their own independent variable, and they come up with their own dependent variable of how to measure that. Okay, so that's what I do with stream tables, and so now when this is done, so hopefully we have finished that second the second part of landforms, right? So I've explained weather, erosion, deposition. And then I can show them on Google Earth different landforms and how they're made through weathering, erosion, deposition. And then the next thing is I need to finish that rock cycle part, because we did igneous rocks and metamorphic rocks when we talked about plate movement and the convection in the mantle, but we haven't talked about sedimentary rocks. Well, another really neat reason to do this string table, and the reason I encourage you to do it is because when it's all over, well, you're going to set the table somewhere and let all the water evaporate out of them, so it'll dry it out, and you can put it up for next year. Well, when that happens, what you'll notice is that you'll get little rocks. Okay, now I mean I call them that. They're just little. They're pieces. You'll get the sand will stick together like sand does when water evaporates out of it. And if in fact if you take one of these before and kind of clump it together and let it all dry out that way, it's kind of neat, and you can pass it around the classroom and say, "Here's a rock." I mean, because what is a rock? It's all these minerals, all these sand particles that are stuck together, and that's exactly what happens. And even though you can easily break it by just crushing it, right? That's essentially how a lot of sedimentary rocks are made. They're made through this process of water evaporating out of it, and it is cemented together. That's what glue is. That's what cement is. Is that well, if you put glue on something, you let the water evaporate out of it, and all the minerals hold whatever together, hold the two pieces of paper together or something. And so that kind of explains what a sedimentary rock is and how sedimentary rocks are made. And in there, I've done before where we've done experiment with that. Like, well, let's experiment with evaporation and gluing things together. And I've had some students that will come up with, well, essentially like a piece of paper. You fold a piece of paper in two, you put salt in the middle of it and put water on it, and then let all the water evaporate and see if it sticks together. And then you can do that again without. Same thing with letting water evaporate out of sand. Here's a big clump of sand ball made with water. Here's a big clump of sand ball made of salt water. And now after the evaporation happens, I want to see which one stays together. Okay, but it's very important to let them know you need a way to measure that. You can't just say, oh, look, this one is staying together. This one's harder than the other one. What's a way that we're going to measure it? And that's our dependent variable. I let my students know whenever we talk about controlled experiments especially, but like, and I think I said this in my last video, that science is about trying to turn the natural world into math. We like math. It gives us hard, cold answers, and we like it. And we try to do science the same way, where we try to have numbers. We're going to put a number with everything so that we have something to go on. So my dependent variable is always going to be something I can put a number with. Okay, so what we've done is, hopefully in this video, is have finished up the rock cycle. Let's talk about how sedimentary rocks are made. And we've also talked about how landforms are made through weathering, erosion, deposition, and given our students some examples of those things. Also introducing that whole concept of experiments, and maybe showing how some models are very good and how they are also limited at the same time. Anyway, I hope this helps, and I'll catch you next time.